Modern humans have been living on Earth for about 300,000 years. But as of now, the Earth is on the verge of destruction. The Earth is going through a climate change, and in time, the Earth will be uninhabitable for humans. Before that happens, mankind needs to find another suitable planet to survive. While it's not easy to find a suitable planet to survive in, there is one planet that is buzzing right now. And if you guess Mars, you guessed correctly. But there's one question. Will humans be able to live on Mars? Welcome to Techmo. Today we will answer the question, will humans be able to live on Mars? Make sure you stay tuned till the end of the video to know the interesting answer to this interesting question. Several organizations have proposed plans for a human expedition to Mars as the first step toward colonization. While landers and rovers have successfully landed and investigated the planetary surface and delivered data regarding ground conditions, not a single person could ever land on Mars. However, there are a number of factors to consider before jumping on board, and the most critical one of them would be the difference between Mars and Earth. The surface gravity of Mars is just 38% that of the Earth, which is very less. Microgravity is also known to induce health issues like muscle loss and bone demineralization. Mars has a surface area of 28.4% of the Earth's. Mars is half the size of the Earth and has a tenth of its mass. Mars lacks a magnetosphere, which would cause solar particle events and cosmic rays to reach the Martian surface. On Mars, atmospheric pressure is much below the Armstrong limit for human survival without pressure suits. The atmosphere is also poisonous, since it is mostly made up of carbon dioxide, approximately 95%, 3% nitrogen, 1.6% argon, and traces of other gases totaling less than 0.4%, including oxygen. And the temperature difference between day and night is significantly bigger than on the Earth, often approximately 70 degrees Celsius, due to the thinness of the atmosphere. However, during dust storms, the day-night temperature difference is substantially lower, since very little light gets down to the surface even during the day. The rovers Spirit and Opportunity discovered that there is less water on Mars than in Earth's driest desert. With mean surface temperatures between 87 and 5 degrees Celsius, the environment is substantially cooler than Earth's. Mars is 52% further away from the Sun. It's only 43.3% of what reaches the Earth's upper atmosphere. However, because the atmosphere is significantly thinner, a higher proportion of solar energy reaches the surface as radiation. On Mars, the maximum sun irradiance is around 590 watts per square meter, compared to roughly 1,000 watts per square meter on Earth's surface. Mars has no rain and almost no clouds. Therefore, it is always sunny, even when it is cold. This means that solar panels can always operate at maximum efficiency. Throughout the year, global dust storms occur frequently that blanket the entire planet for weeks, preventing sunlight from reaching the surface. Temperature decreases of 4 degrees Celsius have been noted for several months after the storm. Mars has seasons similar to Earth's. However, they last nearly twice as long on average due to the Martian year's length of 1.88 Earth years. Can you believe that? All other planets in the solar system have temperature regimes that are more similar to Earth's than Mars. While Mars is normally colder than Earth, in some locations and at particular seasons, it can have Earth-like temperatures. Because of the relatively high amounts of fluorine and related chemicals in the Martian soil, it is harmful to all known forms of life. Plants and animals are unable to withstand the harsh conditions on Mars' surface. However, certain extremophile species that thrive in hazardous settings on Earth have been exposed to environments that are similar to those found on Mars for extended periods of time. Now, since we know how Mars differs from the Earth, we will see how the red planet could be terraformed. Terraforming Mars includes 3 primary processes: warming the surface, thickening the atmosphere, and changing the environment to something Earth-like. Fortunately, these 3 responsibilities are intertwined and mutually useful. Thinning the atmosphere will warm the planet's surface while reducing the quantity of radiation it receives. Warming the surface will also melt the polar ice caps, releasing frozen CO2 and water vapor into the atmosphere, thickening and warming it further. The introduction of terrestrial bacteria, lichens, plants, and animals to the planet will help to stabilize the environment, produce oxygen through photosynthesis, and establish a life cycle on the planet that will assure long-term habitability. The first stage is to make Mars experience a greenhouse effect. This might be accomplished by releasing super greenhouse gases into the Martian atmosphere, such as ammonia, methane, or chlorofluorocarbons. The atmosphere would thicken, global temperatures would rise, and the polar ice caps would melt. It's also possible to concentrate solar radiation and aim it toward the Martian surface using orbiting mirrors. These mirrors, if placed near the poles, would sublimate the ice sheets and contribute to global warming. Conditions will be stable enough for water to flow on the surface once the atmosphere has thickened and warmed. This will necessitate drilling into the ground to release additional methane in water pockets. This will eventually result in rains and the disappearance of dust storms. Microbes, lichens, plants, and eventually animals will be introduced to the planet to help stabilize and replenish the soil with organic nutrients, as well as generate a complete life cycle. Photosynthetic species, ranging from cyanobacteria to purple pigment proteobacteria, will need to be introduced initially. These bacteria would consume CO2 in the atmosphere to produce oxygen. The atmosphere will warm up and become more breathable over time, to the point that humans will be able to go outside without a pressure suit. To ensure long-term stability, an artificial magnetic field will be needed to prevent Mars' new atmosphere from being stripped away and offer more radiation protection. Research has revealed that electromagnetic toruses can be formed around surface bases to produce artificial magnetic fields. Another concept is to use Phobos, Mars' bigger moon, to create a plasma torus around the planet. Since Phobos orbits Mars every 8 hours, constructing this torus would be as simple as ejecting debris from the surface and driving a current strong enough to create a planetary magnetic field with electromagnetic and plasma waves. Building a series of planet-encircling superconducting rings to generate an artificial magnetic field is a similar notion. An artificial magnetic field would generate an artificial magnetotail, shielding Mars from solar particles while allowing the atmosphere to thicken over time. An even more ambitious proposal is to re-establish geological activity on Mars so that it may generate its own magnetic field once more. Once again, there are a plethora of possibilities. To melt the outer core, one option is to launch a succession of thermonuclear bombs. The second method entails sending a large electric current through the planet in order to remelt the planet's metallic outer core. However, how much we can change Mars to suit our purposes is limited. Because of its distance from the Sun, Mars would always receive roughly 40% of the solar radiation that Earth receives, limiting how hot it gets outside. However, the magnetic shield stated previously might be able to help. If the barrier could polarize itself as needed, it could prevent dangerous radiation while amplifying photosynthesis. While adjusting to Martian gravity will always be difficult, there are methods for dealing with it. In the long run, orbiting rotating pinwheel stations that imitate Earth gravity and Martian gravity could be developed. The Earth wheel could provide gravity therapy, whilst the Martian wheel could help visitors adjust to Martian gravity. In the short term, future Martian colonists will need to commit to a health regimen that includes plenty of exercise, a good diet, radiation screenings, and frequent checkups. Medicines and bioimprovements may be developed in the future to assist people cope with the long-term effects of living in a reduced gravity environment. The challenges of surviving on Mars are unquestionably enormous. However, there are solutions, and all that is necessary is the right level of knowledge and dedication. And that is how humans will be able to live on Mars. That's all for today. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content. Let us know your thoughts in the comment section. Until next time.